Hello everyone, myself Vinay Kumaram. I am pursuing PhD in physics. So in this particular YouTube channel, I will be teaching physics, chemistry, and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry, and mathematics, then please do subscribe to my channel. So in my previous video, I have actually started the 7th chapter of 9th standard mathematics, that was on triangles. So I have explained most of the concepts which were there before exercise 7.1, and I have also solved example 1, 2, and 3. So in this particular video, we'll be looking into the exercise questions which are there in this particular chapter. That is, we will solve the first exercise, exercise 7.1. So in first question, you have a quadrilateral like this. So let me draw the figure. So there is one quadrilateral like this in the first question. So this point is A, this point is B, this is C, and this is D. So the data which they have given here is AC is equal to AD, and they are telling that this particular AB line, so this particular AB line is bisecting this particular angle A. So that means this angle will be equal to this angle, because whenever you come across with the word bisect, that means it is dividing a particular thing into exactly two different halves. So now this AB is bisecting A means this angle and this angle are equal with each other. So here what they have given is AC is equal to AD, and here since AB is bisecting, since AB is bisecting A, so since AB is bisecting angle A, therefore here CAB is equal to BAD. So CAB is equal to BAD. I am considering these two triangles, that is ABC and ADB. So in these two triangles, AC is equal to AD, which they have already given, and CAB is equal to BAD because AB is bisecting angle A. Now here you can see for this both the triangle AB acts as one common side. So that means here in these two triangles, AB is equal to AB. So that means here, if you are considering this diagram, I'm just writing this separate like this. So here we are considering two triangles. So here AB is there. The same AB I am writing here. So here C is there, here D is there. So here in these two triangles, AC is equal to AD. AB is equal to AB because AB are common side for both the triangles. So here and also angle A, so that is this particular angle CAB, and here BAD, this particular angle BAD is equal to each other, and AB is common side, and AC is equal to AD. So here according to SAS, side angle side postulate, these two triangles, that is triangle ACB is congruent with triangle ADB. So this is what they have asked in the question, and we have proved that triangle ACB and triangle ADB are congruent with each other. And they're asking what about BC and BD side. So what happens for BC and this particular BD line? BC will be equal to BD because here these two triangles are congruent with each other. So now we will move into the second question in the same exercise 7.1. Here also they have given one quadrilateral, and here AD is equal to BC. So first we will try to draw this particular figure. So you have a quadrilateral like this. So in this particular quadrilateral, here this side is A, this is B, this is C, and this is D. So ABCD is a quadrilateral, and AC is connected, that means diagonal is connected, BD is also connected. So these two diagonals are connected with each other. Now here you have AD is equal to BC. So this is what they have given here. AD is equal to BC, and they have given DAB is equal to CBA. So here DAB is this particular angle, CBA is this particular angle, CBA. So these two angles are equal to each other. Based on this data, you have to prove that here three sub questions are there in the second question. First, you have to prove triangle ABD is congruent with triangle BAC. So which is the triangle ABD? Here this particular triangle is ABD. So this particular triangle is ABD and this particular triangle is BAC. So this particular triangle is BAC. So now let me write this particular figure separately. So here you can see we have one triangle like this. So we have one triangle like this. This is A, B and D. So here there is one more triangle like this. So we have one more triangle like this. So this is also A, B and this point is C. So these two triangles we have to prove they are congruent with each other in the first question. So now here you can clearly see in both this triangle, this AB acts as common side. This particular side and this particular side acts as common side. So since AB is common side, here AB is equal to AB. Now in the same diagram, you can see that this particular side BC, so this particular side BC, this particular side AD is equal with each other. So that means this particular side and this particular side are equal to each other. So now here you can see in this particular triangle BAD is equal to ABC. So that means this particular angle you have to consider and this particular angle you have to consider. So in this diagram you can see BAD, that is this particular angle. So this angle is equal to ABC, which is they have given in the question. So that means this particular angle ABC. So here BAD and ABC are getting equal to each other. And you can see here they have given BC is equal to AD. So that means here this particular BC is equal to AD. So that means here side angle side. So here also side angle side are getting equal to each other. So that means in triangle ABD and triangle BAC, AB is equal to AB because this is common side. So AB is equal to AB because this is common side. And here angle BAD, or I'll take DAB, is equal to CBA, which they have already given. So this is already given. And they have also given AD is equal to BC. So AD is equal to BC is also given. So according to side angle side. So according to side angle side postulate, therefore according to side angle side axiom. So according to side angle side axiom, triangle ABD is congruent with, so this is straight lines. So ABD is congruent with triangle BAC. So these two triangles are congruent with each other. Now we have proved the first question. In the same second question, if you come to the second question, here you should prove that BD is equal to AC. So here BD is equal to AC. So that is this particular side BD is equal to AC we have to prove. And we have already proved this particular triangle is congruent with this particular triangle. So this side should be equal to this side. So that means here since triangle ABD is congruent with the triangle BAC, here therefore straight away BD becomes equal to AC. So here straight away BD is equal to AC. Now in the same second question, we look into the third question. ABD angle is equal to BAC. Here you have to prove ABD is equal to BAC. ABD is this particular angle. BAC is this particular angle. So that means Here also, because these two triangles are congruent with each other, straight away you can write ABD is equal to BAC. So here also, since triangle ABD is congruent with triangle BAC, therefore ABD angle will be equal to BAC angle. So straight away, using SAS axiom, we have proved that these two triangles are congruent with each other. Using that congruency, we are proving BD is equal to AC, ABD is equal to BAC. So first question, if you solve, second and third question, straight away you can put that these two triangles are congruent. So side is also getting equal, angle is also getting equal in second and third question. So now we will move into the third question in exercise 7.1. So in third question also you have one figure. So let me draw that figure over here. So you have one line like this. There is one more line like this. So this is the figure which you have here. This angle is 90 degree and this angle is 90 degree. Name, they have given this as A. For this point it is B, here it is C, and here it is D. And this center point is O. Here BC is equal to AD and this particular angle is equal to this particular angle. Now, based on this data, you have to prove that particular CD bisects AB. So here this particular CD line exactly bisects AB. So that means here you have to prove that OB is equal to OA. So here they have given AD and BC are equal perpendiculars to line segment A, and they have given AD and BC are equal. So here one data they have given, that is AD is equal to BC, and one more data is CBO is equal to OAD, which is equal to 90 degree. Now based on this data you have to prove OB is equal to, so here you have to prove, so I'll write to prove. So here you have to prove OB is equal to OA, because we have to prove that this CD exactly bisects the AB line, because here bisecting means it has to divide the line or anything into exactly two halves. So that means here AB means this particular OB, this particular OA should be equal to each other. So that is what we have to prove here in this particular question. So in order to do that, we can straight away take this particular triangle and this particular triangle and prove that they both are congruent with each other. And based on this, we will try to find out whether OB is equal to OA or not. So now, as of now, I'll erase this particular circles, what I have written here. Now, in these two triangles, BC is equal to AD. First, we will consider triangles. So here we will consider triangle OBC and triangle OAD. So in these two triangles, OBC and OAD, BC is equal to AD. They have already given this. So straight away we will write BC is equal to AD. So here in the data you can see that AB and CD are two lines. So because AB and CD are lines, so here AB and CD are straight lines. So here AB and CD are straight lines. Therefore, this particular angle BOC and this particular angle AOD acts as vertically opposite angles. So because they are vertically opposite angles, they will be equal to each other. So AOD angle will be equal to BOC. These are because these two are vertically opposite angles. So these two are vertically opposite angles. Now you can clearly see this particular angle is 90 degree and this particular angle is also 90 degree. So one more thing is getting equal, one more angle is getting equal, that is OBC is equal to OAD. So here what they have given is OBC is equal to OAD is equal to 90 degree, which they have already given. So what and all things we are getting here? Here we are getting AOD is equal to BOC because they are vertically opposite angles. OBC is getting equal to OAD because they have given their 90 degree. And here they have also given BC is equal to AD. So according to angle side theorem, so according to AAS theorem, so therefore according to AAS theorem, here triangle, what triangles we have considered? We have considered triangle OBC and triangle OAD. So triangle OBC is congruent with triangle OAD. So now because these two triangles are congruent, since this particular triangle OBC is congruent with triangle OAD, since triangle OBC is congruent with triangle OAD, here these two sides should also be equal to each other. That is, OB should be equal to OA. So since these two triangles are congruent with each other, OB should be equal to OA. So since OB is equal to OA, here O is the midpoint of line segment AB. So if O is the midpoint of AB, then CD is bisecting AB. So then CD is bisecting AB. So this is what they have asked in this question, and we have proved that. Coming into the fourth question in this particular exercise 7.1, here you have two parallel lines, that is L and M. So there are two parallel lines which is named as L and M, and there are one more pair of parallel lines like this. One more pair of parallel lines are there like this. These lines are named as P and Q. So now here this point is named as A, this point is named as D, this is C, this is B, and AC is connected like this. So that means here you are getting this triangle and this triangle. So I have to prove these two triangles are congruent with each other. So here since L and M are parallel to each other, so since L and M are parallel to each other, so AD will be parallel to BC because AD and BC are lying on L and M. So AD is parallel to BC means these two angles acts as alternating angles because AC is a traversing line like this. So here this particular angle and this particular angle acts as alternating angles. So therefore here angle DAC is equal to angle ACB. So this is because they are alternating angles. So this is because they are alternating angles, and you can see here AC is the common side. Before going into common side, here you can clearly see ABCD is a parallelogram. So here ABCD is a parallelogram. So ABCD is a parallelogram because here AB is parallel to DC, AD is also parallel to BC because L and M are parallel, P and Q are parallel. So it is forming a parallelogram. So in parallelogram, opposite angles will be equal to each other. So here this angle will be equal to this particular angle. So therefore ADC will be equal to ABC because ABCD is a parallelogram. So since ABCD is a parallelogram, angle ADC will be equal to angle ABC. So that means here we are getting DAC is equal to ACB, and we are also getting ABC is equal to here we have ADC is equal to ABC. So here ADC is equal to ABC. This is because they are parallel to each other. So here AD is parallel to BC, and this is because ABCD is a parallelogram. Okay. Now here in this two triangles, AC acts as the common side. So here AC acts as common side. So AC will be equal to AC since they are common sides. So here according to angle side theorem, so according to angle side theorem, so angle side theorem, here triangle ACD, so that is this particular triangle ACD is congruent with triangle ABC. So ACD is congruent with triangle ABC. This is fourth question. So this is all there in this particular video. The next questions which are there in this exercise I will be teaching in my next videos. So until then, if you want to learn more physics, chemistry and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.